Hey guys, today I will show you how to multiply two matrices. And before I get into examples, let me highlight one point. Say you have a matrix A which has a size n times m. And as a quick reminder, a size or an order, sometimes it's called a dimension, is just the number of rows and a number of columns. So say this matrix A has n rows and m columns. And say we have matrix B which contains p rows and q columns. Matrix B has p by q size. The thing is, sometimes you are not able to multiply these two matrices, and it's all depends on their size, on their order. So sometimes we are not able to perform multiplication, so the product does not exist. You can multiply A times B if only if the number of column in the matrix A, M, has to be equal the number of rows in the matrix B, if only if. So if this M and P, these inner numbers, equal each other, so if they coincide, if they match, so then the product exists. I will show you what I mean by that. Say you have matrix A containing the following elements: 1, 2, 3, 4, 0, 1. And say you have matrix B containing the following elements: 0, minus 1, 3, 5, 4, 2. Now, does the product exist? So let's see. So matrix A has 2 rows and 3 columns, 1, 2, 3. So matrix A has the size 2 by 3. Now, matrix B has 3 rows, 1, 2, 3, and 2 columns. Since these two inner numbers, they're the same, 3 and 3, so the product, so they're the same, so the product does exist. And basically we can define the order or the size of the product matrix. So the size A times B is going to be 2 by 2. So again, the size of their product can be defined by just taking out these outer numbers. So it's 2 and 2. Now, recall that if we multiply normal usual numbers, let's say 2 and 3, 2 times 3 gives you 6, and 3 times 2 gives you also 6. So if you multiply normal numbers, doesn't matter in which order we can multiply, the result would be the same. So for matrices, for matrix multiplication, the situation is completely different. If you swap the order, if you change the order, generally speaking, the result would be different. So if you multiply matrix A by matrix B, so generally speaking, it's different from multiplying matrix B by matrix A. So in this case, if I multiply matrix B by matrix A, so the product does exist. I'm going to multiply B times A. So the size of B is 3 times 2, and the size of A is 2 times 3, 2 by 3. So since these inner numbers, they are the same, it's 2, so the size of their product, B times A, is gonna be defined by these outer numbers, which is 3 by 3. So the size of the product is going to be 3 by 3. So by this, you could conclude that generally speaking, and also for these two matrices, so their product AB and B and BA, so their product AB and BA would be different, since these resulting matrices, they have different size. Right, now let me dive into examples and show you how to actually multiply two matrices. Say you need to multiply A times B. So first of all, check to see if their product exists. So the size of matrix A, so we have 2 rows and we have 2 columns. So the size of matrix A is 2 by 2, is a square matrix. So now the size of matrix B is going to be 2 by 2, so it's going to be the same. So we have 2 rows and we have 2 columns, so it's 2 by 2. So the product does exist and we're able to perform multiplication, and basically, as I mentioned before, we can define basically the size of their product, their resulting matrix. So since these two inner numbers, they match, so 2 equals 2. So these outer numbers, which is basically 2, also 2, they give us their size of their product. So the size of their product of the resulting matrix is 2 by 2. So it's going to be the matrix the same size as the original ones. So the size of their product, A times B, is going to be 2 by 2. So the product basically has the size as the original one, so it's going to be 2 by 2. So let's perform that multiplication. As a good rule of thumb, you always multiply a row by a column. So for the first one, you have this first row and you take this first column and you multiply the corresponding elements. So you multiply 2 by 4, and you multiply 3 by 1. And you want to add them together, you want to sum them up. So this is your element on this top left. Now, moving on, you want to move on to the second row in the first matrix. And basically you do the same with the second row in the first matrix. So you multiply this -1 by 4 times 4, add, and you multiply 0 by 1, which is basically 0. But anyway, I'm going to spell it out. 0 times 1. Now, we're going to proceed the same process with the same matrix A, but we're going to move to the second column in the matrix B. We're going to take the first row and we're going to multiply the first row by the second column. So we're multiplying 2 by this -2 and 3 by this 3. And this element goes over there. So again, 2 times -2 plus, we always add up, 3 times 3. So 3 times 3. Now, we're moving on to the second row in the first matrix, and we do the same with the second row in the matrix A, with the second column in the matrix B. So minus 1 we multiply by negative 2, and 0 we multiply by 3, and we add their products. So again, minus 1 times negative 2, and we add 0 times 3, 0 times 3. Alright, so hopefully you've noticed the pattern. So you always multiply again. I'm going to repeat myself. You always multiply a row by a column, and you add up the corresponding products. So all you need to do is just finish this computing, this calculation. Often most of the people just skipped over this step and do it in their head, so go ahead. And all you need to do is just compute. So 2 times 4 gives you 8, plus 3 gives you 11, and it's going to be this element in the top left. Moving on, this is 0 and this is negative 4, leaving you with negative 4. Let's move on to the, this is negative 4 and plus 9, leaving you 5. And finally the last element, or the last entry. So this is 0 and this is positive 2. So you would be left with 2. So this is your resulting matrix, or your final matrix if you wish, for this multiplication, for this A times B. Now let's multiply B times A in the reverse order and see that basically we would get the different result. So again, your matrix B has size 2 by 2, and your matrix A has the same size 2 by 2. So basically the product does exist, so it's going to be 2 by 2 matrix, it's a square matrix, everything seems fine. Go ahead. So the same rule, keep in mind, row by column. So we're going to take the first row and we're going to multiply by the first column in the second matrix. So 4 times 2 plus minus 2 times minus 1. This is your first element. Moving on, the second row, the first column. So 1 times 2 plus 3 times minus 1. Now, moving to the second column, we're going to take the first row and the second column now. So the first row, 4 times 3 plus minus 2 times 0. So the corresponding entries, minus 2 times 0. And finally the last element. So the last row in the first matrix, so 1 times 3 plus 3 times 0. And all you do is just calculate. Again, if you are fine with this, if you are comfortable, you could simply skip over this step and just write the final matrix. So become 8 plus 2, that gives you 10, that gives you 10. So 2 minus 3, negative 1, and these 2, so this is 12, and that gives you 0, so you would be left with 12. And finally the last, this is 3 and this is 0, so you would be left with 3. So this is your resulting matrix. So this is your product B times A. And if you look back at what we did for the first one, A and B, so as I mentioned before, generally speaking, A times B is not equal B times A. So always keep in mind, so this rule does not work over here, so it fails. Now, say you need to find the product A and B. So now I'm giving you not square matrix. So the first case was kind of a trivial and easier case, if you will. So let's take a look at like rectangular matrices now. So the size of matrix A is, so you have 2 rows, 1, 2, and you have 3 columns, 1, 2, 3. So the size is 2 by 3. Now, for matrix B, we have 3 rows, 1, 2, 3, and we have 2 columns, so the size is 3 by 2. So again, check to see, so the innerst numbers, they're the same, 3 equals 3, so it's the same. So the product does exist, so we're able to perform multiplication. And this inner number, these outer numbers, gives you the size of their product. So the product A times B has the size 2 by 2. So it's a square matrix 2 by 2. So let me go through this kind of quickly. So the same rule, so keep in mind, you always want to multiply a row by a column. So you take the first row and you multiply by the first column in the second matrix. So you multiply the corresponding integers, the corresponding elements, and you add up their products. So 1 times 2 plus 2 times 1 plus 3 times 4. This is the first element, top left. Now, moving to the second row in the first matrix. 0 times 2, so and the same process with the first column in the second matrix. So 0 times 2 plus 4 times 1 plus minus 1 times 4. Now, moving to the second column, so ignore for the rest the first column, so it's done. So we're going to work on the second column in the second matrix, and we're going to take firstly first row in the first matrix. So 1 times 5 plus 2 times 0 and plus 3 times 1. And the last element, finally, 0 times 5 plus 4 times 0. So again, the second row, the first matrix, the second column, the second matrix. 4 times 0, and finally, negative 1 times 1. So all you need to do is just calculate, is just compute. So it becomes, so 2, 2, 12. So 2 plus 2, 4 plus 12 gives you 16. Over here 0, 4, and negative 4. So 4 minus 4, you would be left with 0. Over here you have 5, 0, and 3. So you would be left with 5 plus 3, which is 8. And finally the last element, so it's right down, right bottom over here. So this is 0, 0, and negative 1. So you would be left with negative 1. So that's your answer. So to be honest with you, the process kind of tedious, and if your matrices are kind of big ones, so if your matrices get bigger, so it takes time, and you have to be very, very careful with corresponding elements. You know what I mean? So it's tedious, but hopefully you've got this grasp, and there is a pattern, and hopefully just all you do is just follow this pattern. So row by column and add up the corresponding products. Now let's switch the order and multiply them in the reverse order. So matrix B has 3 rows, 1, 2, 3, and it has 2 columns, 1, 2. So it has size 3 by 2. Matrix A has 2 rows, 1, 2, and it has 3 columns, 1, 2, 3. So the size 2 by 3. So the product does exist, since these inner numbers the same, so they equal 2 equals 2. So, and the size of their product, so B times A, the size can be defined by taking these outer numbers, so which is 3 by 3. So the size of their products is 3 by 3. So go ahead and find their product. So it's going to be kind of a large matrix. So I need a space. Start over with the first row in the first matrix and the first column in the second matrix. So keep in mind that there is a pattern. So you want to multiply each element in the first row by each corresponding element in the first column, and you add up their products. So 2 times 1 plus 5 times 0. Moving on, second row, the first column, 1 times 1 plus 0 times 0. And finally 4 times 1 plus 1 times 0. Let's fill in the second column. So the same pattern to keep in mind. So the first row by second column. So 2 times 2 plus 5 times 4. Moving on, 1 times 2 plus 0 times 4. And finally 4 times 2 plus 1 times 4. Now, finally, let's fill in the last column. So we're going to consider the last column in the second matrix, and we're going to start over with the first row in the first matrix. So 2 times 3 plus 5 times negative 1. Moving on, 1 times 3 plus 0 times negative 1. And finally the last element, so right bottom, 4 times 3 plus 1 times negative 1. So all you need to do is just calculate. So it becomes 2 plus 0, 2, 1, and 4. The second column, so 4 plus 20 gives you 24. Over here 2, 8 and 4 gives you 12. And the last column, let's fill out. So this is 6 minus 5 gives you 1. Over here 3 plus 0, that gives you 3. And finally the last element, that's 12 minus 1, they would leave you with 11. So that's your resulting matrix for this multiplication, B times A. I'm sweating like hell. It's hell here. No, it's bloody hot. I wanna remove it, but I can't. I have nothing inside. I cannot be naked. Lord, why so hot? Right, with this being said, I hope it has been helpful. So, as a kind of a recap, as a summary, so it literally tedious. It's a little bit tedious. It's not little bit. It is tedious, and you have to be careful with just matching this and multiplying these corresponding elements, because it's so likely to make this little slightly errors, slip ups, slip ons, you name it. So just you could double check, you could triple check. If you have the answer key, you could check it with the answer key or with your teacher, or just with a calculator, because some scientific calculators, they can do this work over the computers. Anyway, hopefully you get the grasp of it. So again, if your matrices get bigger, so it's more this kind of arithmetic with calculations, involved, engaged over here. Anyway, good luck. Huge thanks for watching and anyway, and I know everyone hates maths, yes, everyone hates maths, especially like this. So, but if you like my video, please hit this like, share with your friends, leave the comments down below, and be sure to smash that subscribe button if you haven't, so you will not miss out my new videos. The thing is, the product of these two matrices sometimes do not what? B 3 times 2. Why 2 times 3? What? What's the hell we are right? Often most people just skipped over this step, this kind of intermediate step. Yeah, something like this.